This work is in conjunction with the U.S. Army Corps of Engineers and the University of Texas at El Paso. So what's our motivation for our work? Basically, this is for intelligence analysis, right? So the main idea is you have a corpus of news stories, a news data set, and what you want is basically to find a story or the evolution of a concept around a long time. So for example, you have different events that are related to some topic or to a seed document. In our case, we basically the input that the user gives is a seed document, right? So for example, an article about ISIS or some terrorist act. And what the intelligence analysis community is interested in is basically looking back in time and trying to see if there are news that could help predict or try to find a correlation between this news and the future news. So the main objectives of this particular paper was, as I already said, try to find the evolution of a concept. This is through finding document chains of news stories. And in this case, what we use, there are several different storytelling algorithms or connecting the dots algorithms. And in this case, what we introduce is the concept of diffusion. So diffusion, we use it as there are several events going on time, right? And what we mean by diffusion is that we want an idea to basically diffuse in time. So something that happened 5 years ago will have less of an effect well, not an effect, but will matter less to a current event than something that happened 1 year ago, right? And so when we compare this to similarity-based evolution, similarity is basically you try to find out what happened recently that actually is related somehow to this event. So for example, in this case, you can see the output of our framework basically starts in 2011, where you can, the news headline is "Strike Reflects US Shift to Drones in Terror Fight." And then it goes to another event almost 3 months later about a decrease in strikes from US drones. And then it goes 1 year later to the United States trying to thinking about having a spy drone base in Africa, which was basically because of the Boko Haram. And yeah, and in general, we see this kind of evolution of one particular topic. And basically, the seed document here was Obama relaxes rules for striking ISIS in Afghanistan. And so the main goal, which is not really tackled in this paper, but the future goal is prediction, to try to predict based on this this chain of documents, try to predict what might happen in the future or which entities will be like the protagonist of a future story. So this is our framework. Initially, we do some pre-processing, we do entity extraction, document modeling, topic modeling, and with this, we get some TF-IDF vectors, some topic models. We basically run this through a candidate generation function, which based on the seed document, we reduce the number. So we take the whole corpus, which is for this experiment, it was more than 4 million documents, and we basically reduce it to just a subset of articles that are very similar topically to the seed document, or not very similar. We use KL divergence, and the user can actually set the divergence threshold, so you can choose however how significantly similar are the two stories or the stories. And then we run this through an optimization function I'll explain next the objective function that we optimize. So basically we have this set of candidates and we have a seed document. And then the free variables here are segment, well, they're turning points. We call this turning points. So this means that at this particular turning point, there is a significant event or something that changed between the documents. So what this means is basically that we're just dividing the timeline into segments that are kind of isolated between them. But what we want is basically to correlate these segments sequentially. And the other variable that we're using is free variables is a weight vector. So basically we're trying to see which documents actually are relevant to our optimization or to this particular seed document. So the objective function is built from the ground up with several different concepts. The first one is that we are trying to minimize incoherence between the documents that belong to the same segment. So this is an example of what happens if you just use incoherence minimization or coherence maximization. So basically what happened was that all of the turning points would be they would be in the same region, because this minimizes the distance between all the documents, but that's not really what we want. So we added a date difference penalty, and this is just an example of how the date difference penalty affects the optimization. This date difference penalty basically just penalizes a lot when you have like a very large segment, and so that's why we decided to include it. Next, what we want to minimize is similarity between the segments. So we want the segment, for example, the segment in orange to be very coherent within that particular segment, but we also want it to be they're different from the next segment, right? From the red segment or the green segment. And we also penalize for segment overlap. So we added just a Gaussian function to each of the turning points, and we just added a penalty there for to avoid overlap. Yes?
Can you elaborate more on the difference between the coherence and similarity?
Yeah, so it's like clustering, more or less. So you have similarity within so incoherence, it means, so we're trying to minimize this, right? So in coherence, you try to minimize incoherence within a particular segment, right? And then you try to minimize similarity between the segments, right?
There's cross segment.
Yeah. Yeah, exactly. And so then to like the purpose of the weights and the uniformity penalty is basically we have this, let's say that each of these belongs to each color represents a particular topic, right? So for example, in the segment on the left, there's 2 red news articles and 1 blue. And we basically want to get rid of this blue, want to get rid of this blue article and of this red article here. So that's basically what the weights do, and this is automatically done through the optimization. And also, we added a uniformity penalty for the weights because if we didn't, basically all the weights were set to 0 because that was the optimal value for the objective value. And so the way that we actually evaluated this framework was twofold. First, we did a quantitative evaluation. In this case, we use a dispersion coefficient, which basically penalizes if you. So, for example, in this case, we have relevant document A, and this is similar to relevant document B. But if it's similar to all of these documents, then it doesn't really make sense. There's no diffusion, right? So it actually adds a penalty if document A is similar to document C, or to document D, or to document E. And the penalty is larger the further away they are from each other. But this was just to evaluate the results. This was not included in our optimization framework. And so then we did this quantitative comparison with several different clustering methods. So we did it with our approach, similarity-based approach, k-means, agglomerative clustering, and spectral clustering. Here the y-axis is the average dispersion coefficient, and the x-axis is the distance threshold between the vectors of the news stories. And so basically what we were trying to do was maximize the average dispersion coefficient, and you can see that our approach is better for most of the different distance thresholds. And here's a case study that we did with so basically state-of-the-art with metro maps. This is actually from Dr. Leskovec's lab, for Dr. Daphna Shahab. And so, for example, in this case, the metro maps output it's basically very similar. So they talk about an aid operation, and then the death toll about Syria in Syria's war, and then again the first document is about the death toll, and then they talk about the elections. But all of this is within the very similar time frame, right? Like from February 2014 to March 2014. And so what the intelligence analyst that was working with us was interested in was going further back in time. And so, for example, in this case, we have like our first document is about torture allegations against the Syrian government. And basically, if you look at the whole evolution of the civil war in Syria, when it started, it was related to abuse of power from the Syrian government. The next article is basically about the mission of the Arab living in Syria. They wanted to supervise the war, and this is just at the beginning of the war. And then the next article talks about all of the refugees that were fleeing to Jordan from Syria, from the war. And finally, this article it's curious because this article was published the same day, well, one day before the Syrian government was accused of using chemical weapons on the rebels. But it's very related. And so then we end up with the consequence of basically the Syrian vote with respect to the civil war. And this is another case study with Iran. So in this case, I will just focus on our approach. So the first document basically talks about the position of Russia versus the nuclear program of Iran. They say that Russia is asking for something in return to actually stop them. And then the next article talks about how the Russians have aided Iran's nuclear program from the start, and how they contributed with the scientists and well, the nuclear, well, I don't, with what do you call it? Well, they just contributed with materials to enhance the nuclear program. And then next, they talk about how the negotiations with Iran were over. Well, they resumed, and then how they were over, and then how the U.S. was planning to enforce Iran sanctions. So there's a thread here about how the Iran's program has evolved, like from the beginning with Russian help, and then how the negotiations have stalled and continued and stalled. And so this is a very preliminary analysis of what we could do with prediction. We did just a very simple regression analysis to see if we could actually try to predict words or entities that would be present in the future based on a current article. So in this case, the current article is on the left. These are just the entities that are inputted as to our system. And on the left, here in the middle, you can see the expected word clouds. So these are actual articles that were published around a month after this particular article. This was published several days after it, and this was published at a different date and time. And you can see that there are several terms that repeat themselves here, like Paris attack, Belgium, Brussels. In this case, Syria, Islamic State. So we think that this has promise, in particular because it was we used a very simple linear regression, and we think that if we use a better machine learning algorithm, it would probably work very well. So in conclusion, we think that our framework basically enhances the understanding of the topic. The stories are coherent, and it also shows the diffusion of the topic over long periods of time. And as future work, we're planning on improving this prediction part, and also implementing a streaming version of the framework so that we can actually update it on the fly. Like, just as news are published, we can update our model. And that's